Hey guys, this is Fred from Pretty Fly Games, and today we're going to continue with our top-down car controller built in Unity. In this episode we'll continue to make our complete car racing game using the components we have already developed. We will add a race timer and also the events that signals when a race is completed. We'll also fix some tiny bugs that we have in our other components to make sure that they work well when the cars are spawning dynamically. I've been getting a lot of questions about how I made a racetrack for this tutorial series, and it's using the tile map system from Unity, so it's just a regular grid with the tile map renderer and a tile map. So how you go about actually painting this is you go to Windows and then you have 2D and tile palette. Now I usually work with multiple screens. But if I only have a single screen, then I usually dock it next to navigation here. And then simply what I do is, if we go for racetrack and want to create a start line, then let's find an appropriate tile for that. So like this one. And then we can draw that. I can use my keys to rotate this tile. Like so. And yeah, then I've fitted the centerpiece of it. So that's essentially how you draw on this grid, and you can select over here which tile you're drawing to, and you can see that the active tile map says background tiles here, and if I click racetrack, and then it changes to racetrack. So if I want to change the background tile, I just select that and draw something like this on it, and it will change. So that's how I've created this track. Quite simple, huh? So now we can tackle the next problem, which was that the AI cars were driving backwards when the race started. So as soon as the countdown is done, they are driving backwards. And as I said before, the reason for that is that they don't understand that there is a countdown state. And we need to ensure that they do. So let's go into scripts and go to AI, open the car AI handler. Then let's scroll down to our fixed update, and in here we will check that if the game manager game state is countdown, and if it is, then we will return. We will not execute any of this code, and that will cause the AI to remain in place because this start coroutine stuck check will never run, so they will never believe that they are stuck in reverse. So let's save and try that in Unity. Alright, so now we have our countdown, and the car AIs are no longer reversing. So that was a quick and easy fix. To speed things up, I've added the checkpoints from the tutorial checkpoints and lap counting tutorial. And well, we have different checkpoints like checkpoint 1, 2, 3, 4, etc. And the last one is number 7, which has the 7 which has the is finish line set to true. So when the cars are driving around, they will start counting laps and that they have complete checkpoints. But we also need our position system to work. So let's go to our main camera. Let's open the prefab and let's find our position handler and add that, and yeah, save it. And now we can try this in Unity and see how it goes. So if we now pause the game and we look at lap counters, we can see that it's actually 0. And the reason why it is 0 is because the lap counter system doesn't expect cars to spawn. It expects them to actually already be in the scene. So that's why we are seeing position 0 on these cars when they are passing the finish line. So the checkpoint system is actually working, but the position handler, which decides which car is first, does not work. So let's fix that, and let's open our position handle in Visual Studio. So if we look at our script here, we can see that in the awake function it is checking if there are any car lap counters in the scene. So the awake function will actually not respect the code execution order that we set before, where we stated that the spawn cars should start first. So to solve this, we simply move our code from awake to start. Then it will call awake first, and then it will call start. But the start will respect the execution order of the script, so it will be called after spawn cars, which means that there will be cars in the scene. Now we want as well to check if this leaderboard UI handler is present or not. Right now it's not enabled, so it will throw an error. So let's just check if is not null, then we can use our leaderboard UI handler, and the same thing down here when we are updating it. Alright, so if we save now and go back into Unity, it should work much better. So if we start game, we can now see that, okay, if we pause it and we go into our main camera, we can see that we now have 4 lap counters, which is the number of cars we have. So that's great. So let's unpause and let's just drive around and complete a lap. And there we go. And see, I'm number 1. So that is now working as it should. With our current code, nothing will happen though when we have finished the race, and the cars will just keep on going because they are never updating the game state. So the game will just keep on running. So this is something that we need to change. And it really depends on your game, what you want or how you want it to be triggered. But in this game, we are going to focus on the player. So if a player has finished the race, we're going to say that, yeah, it's over, it's done. But it could be also that you want to allow the AI players to actually finish the race, and then you need to implement that in a different way. But we're going to focus on when the player has entered or completed all the laps, then the game is over. When a race is over, we want to show the position of the cars. So let's go into our canvas and we want to show the leaderboard canvas. So let's open that and let's enable our leaderboard canvas. Alright, so now it shows up in the game, and if I look at the game view, I can see that I have my leaderboard here. So what we want is this canvas to show up when a game has completed, and we need to have an event for that. So let's actually have a look at our leaderboard UI handler in Visual Studio. So this script also assumes that all cars are available right when the scene starts, but they're not. So let's fix that, and we'll do it the same way as we did with other scripts. So let's just move it down to start, because then the cars will be available when it starts. Then we don't want our leaderboard UI handler canvas to show up at the start. So we'll grab its component in the awake function. So let's take our canvas and we use get component, and then we set it to enabled equals to false. So one problem is that when the cars are starting, they are going to call this update list, and they are starting before we have actually executed this code, so that will throw an error. So what we can do is we can add a simple state variable to see that, okay, are we initialized? If we're not initialized, then we're not gonna run this. So when are we initialized? Well, we are initialized when we have fixed our UI list and we are ready to update it. So we'll put is initialized after we've done that, and then we will check in our update list if we are initialized or not. So now we need to figure out when to show this, and we want to show it when the race is over, but this component has no way of actually knowing that. So let's make some changes to our game manager, and we'll do it in a sort of more generic way. So what we will have is an event. So we will be using the events that we created before, and we will, well, use the same methodology for that. So we're going to use event action on the game manager, and we're going to make an event called on game state changed. So when this is triggered, the other scripts know that, okay, the game's change has, or the game state has changed. And we want to use system, so we can get rid of the error here. Okay, perfect. And then when we are changing the state, we want to flag this, or we want to call get the event to trigger. So what we do is we are going to make a new function for that, and we'll add it before our events. So we'll have a change game state function that takes in a new game state, and we are checking that, okay, is the new game state different from the old game state? If it is, then we will assign the new game state, and we will invoke our event that this has changed. Perfect. So when we then have our on start, which is the first state change we have, then we don't want to change that directly, rather we want to use our new function, game running. Then we will need on race completed, just as we have on race start. So let's add that, on race completed. And of course this needs to be triggered in some way. And the script that knows when a race is completed is the car lap counter. So the car lap counter knows that, okay, when has a car finished the race? Well, it's in this part. So it's gonna have its is race completed set to true. And right now it's just showing the position for a long period of time. What we want to do in this function is we're gonna check, okay, are we the player? And if we are the player after this, then we want to be able to do something. So what will we do? Well, first of all, we want to get our game manager to trigger our on race completed. So we'll call this function right away from the game manager. Then we want to do something that I think is kind of fun. We want to, instead of just having our player stop right when it hits the finish line, we want it to continue racing but without the player's input. So we will enable its AI handler and allow the AI to take over right in the middle of when it's racing. So what we can do is we're going to get a few components. We're going to get our car input handler, and we're going to say that it's no longer enabled, so we're not accepting input from the player anymore. And then we will get the car AI handler and say that, okay, you're enabled, we're enabling that, and the A star light as well, so it can avoid things if needed. Alright, so if we do this, then when the player has finished the race, it's going to be taken over by the AI, and we're going to trigger our on race completed event. So now we can go back to our leaderboard UI handler, and we want to use these events. So in the awake function, let's hook up the on game state changed, and we're going to call a function called on game state change, which does not exist yet, so we need to create that. And let's add it after this, so we'll call events. And we're going to have on game state changed, and it needs to include the game manager, because that's how we defined the event. And we're going to check the game manager instance and get its state and check that the race is over, and in that case we're going to enable our canvas. Now there are a few things that you need to be mindful of when doing this, which is sort of a little bit dangerous, and that is we are hooking up this event on the game manager, which is a singleton. So our game manager will survive scene changes, but this script will not. So when we have actually subscribed to our event, then on the game manager's side, it's going to have a list of scripts that are subscribing to this. And this particular script is going to get destroyed. So it will have a null reference here, and it will throw a lot of errors that will be hard to understand. And the most important thing is when we are hooking up events on a singleton is that we remove them when we get destroyed. So we're going to add the onDestroy event. So when this game object gets destroyed by, for instance, a scene change, then we are going to unhook the event on the singleton as well. So we'll use the minus equal and then the name of the event. That's gonna unhook that event. Okay, so let's save this and try this in Unity and see what happens. So I'm the yellow car up here. They all look the same or kind of the same, so it's hard to tell, but yeah, I overtook the AI, so I'm in the lead now. And yeah, I'm at first place, which is awesome. And then I'm finished. All right, so now I can't control the car anymore because it's actually handled by AI. And I can see that, okay, I have the leaderboard here, and it says, well, yellow car is first, which it was, and then we have the, whoa, look at that, it's bouncing on the other car. That's quite cool. So the second car is the blue car, third car is the yellow car, and the fourth car is, well, the yellow car. So that's correct. And yeah, so now our leaderboard system is working, but we also want some dialogue to show up here, like, whoa, you completed a race, and maybe show your race time, because that's important. So let's add that as well. So let's make the UI for the timer. So let's open our canvas in-game, and we'll use the leaderboard as a base for that. So let's duplicate that, move it over here, rename it to time canvas, and we can get rid of that part, and the header text is going to be our timer, so it should look something like that, and we can change it to time text. Background image, let's make it let's increase the alpha so you can't see through it because it's slightly annoying. And then we want to change the height of this. Well, the background image, let's actually stretch it so it fills the whole area. And the same with the text, it can fill the whole area without any offset, like that. And then we can center it. And let's change the color of our text so it becomes fully white. And maybe make it 150 or 100, something like that. And let's move it up to the right corner, anchor it to the top right. And as well, the time text, let's make it bigger, 80 maybe. Yeah, that looks okay to me. And then we can use the fancy outline that we did before, outline. And let's see, -3 was the setting we had before, I think. And we can put the alpha to full. All right, so now we have an object, which is the time object, and it's fitted inside our canvas. And what we need now is we need a script as well to control this time. And we can create that in UI. So let's create C# script. Let's call it race time UI handler. And let's let it compile for a little while. And then let's drag and drop it onto this object here. Okay, so now we have our time. And let's actually apply this to our UI canvas. And yeah, that looks about right. So let's take our race time UI handler and open that in Visual Studio. So let's start by removing the update function, and then we want to grab our text, which is included in the Unity engine.ui. So let's use that. And we also want to have a time when we have last updated this. And the reason why we are doing this is because when you're updating text objects, it takes a little bit of performance. Even though it's 2022, it still takes performance. So we don't want to do that very often. Actually, we shouldn't do that more often than required. And if we're running a game at 60 frames per second, then we are wasting 59 frames by updating it every frame, because we don't need to do that because the text value or the timer has not changed. So we'll come into that later. So then we need to grab our text component. So let's do that in awake text component and assign it to time text. And then we want to update our time, and we will do it in a coroutine. So let's start our regular coroutine and stuff like that. So and we want to start this coroutine when this shows up. Okay, so we will have some type of race timer that we will receive from somewhere later on. We just put it to 0 for now, and then we want to check okay, are we going to actually this needs to be inside the while loop. Hold on. Right. So then we want to check, is this different from last time that we updated it? So has any time passed? And if it has, then we want to do something, and then store the last update time. So then we are ensuring that this does not update more often than once per second. And we can have, since we are using a coroutine, we need to well, make sure that it runs all the time, and we want to use yield return wait for seconds, so it waits here until it tries to run again. Okay, perfect. So what we have done is we have our race time, which is going to be a float, and it represents the race times in seconds. So we want to have a time that has the format like minute, minute, second, second. Okay. So we divide that into two parts. And actually, I was ahead of myself a little bit. So let's do it like this, race time. So our race time in minutes, we're going to use math.floor, and we're going to take the race time and divide it by 60. That way we get minutes. Then we want to extract the seconds. So we do the same thing, but we use this sign here, which is the modulus operator, and do it with 60. So that will bring out our time in seconds. So what we need to do then is we need to put this together in a way that we can format it. So what we will do is we're going to say that the time, the text component of the time text is going to be race time in minutes, and we format it with a 0, 0, so it's always 0, 0 or 0, 1, etc. And then we add a colon and then a race time with the same format here. Perfect. So the only part missing now is the actual race time, because it's 0 all the time. So where should we get that? Well, we already know that our game manager can handle that, because it keeps track of when a game has started or a race has started and finished. So let's add some timing for that, and just add a comment, and we will add a race time start, or race started time, race completed time. So when the race is starting, what we want to do is we want to go down to our on start, on race start, and here we will simply take the time that is right now when this event is happening. And when the race is completed, we want to do the same thing and store the race completed time. And then we want to create a function called get race time. And that's going to be a public, so we can use that from other places. And if the the race is over, then we will take race completed time minus race start time. That will be, well, how much time has passed. But if it's still running, then we will take the current time minus race start time. Okay, perfect. So if we go back here and start using it, so then we have game globals, game manager instance get race time. Awesome. So let's save that and try it in Unity. Alright, and nothing showed up, so we need to figure out what we did wrong. Let's open our in-game canvas in-game and look at our time canvas. And yeah, we have our leaderboard UI handler stuck to this, so let's remove that because that hides it. So that was a bit sloppy of me. Let's try that again and see how it works. Alright, so now we have our beautiful timer running here, and we have our car. So let's just finish the race and see that our UI as well shows up the leaderboard, and also that the timer maybe stops when we have completed the race. Alright, there we go. So the leaderboard shows up and we have our timer that stops, and we can also add our race time here and some other information if you want to do that. So next up in the fixing list is the ghost car recorder. So if we run a game now, we can see that we are getting well, 4 ghost cars, and they are created for the AI and the player, and then they stop when they reach this point because they don't know when the race has finished. But now we have implemented all the events for that, so let's go and fix our race car ghost recorder so that it works correctly. So let's go into scripts, ghost car, and open the ghost car recorder in Visual Studio. So let's use the same events as before. So let's hook up our on game state changed in the game manager, and let's add the events for that. So we are reusing the same events as before. So be careful again about using the on destroy, so we unhook our events. And right, so our code now is that we are starting the recorder when this is started, and we are saving the car position after a while. So let's remove those. And what we want to do is we want to check the events. So when the state has changed to running, then we want to start record. So we'll use our start coroutine record. And then when the state has changed to finished or race over, we want to take our save position CO and run that. So the save position CO, why we are running this and not calling the save directly, is because we want it to, well, pass a little bit over the finish line and then stop the recording. So I'm gonna put this to wait for seconds, like 1. So once the race has completed, we're going to record 1 more second of it, and then the car is going to stop. Okay, so let's save that. And another sort of annoying part with this is that it is recording the AI and the player. And I mean, we don't want to record the AI, we only want to see the player and play back the player. So let's check that in the start. We're checking, okay, is it not the player? If it's not the player, then we're destroying this script and we're returning. So that means we are not creating this ghost car. So then we will get rid of the playback as well. Alright, so let's save that and go back into Unity. Now, one slightly annoying thing with recorded playback is that the car is actually sort of above the other car, causing it to well, get different colors. And the reason for that is because the sorting layer of the ghost playback is the same as the car. So sometimes it will overlap and it's slightly see-through. So if this is above a yellow car, it will become orange. So let's just bring our ordering layer down to -1. Then it will be behind the car at least. All right, so let's play. And now we will still have our original playback from our recording. So we need to complete the race at least once to get a better recording. And yeah, so let's do that. So now the new recording will be saved and it will continue for 1 second. So if we press play now and we don't drive, then we should get our new ghost recorded from this player only. So there we go. So there we have the car and it's going to finish the race. And yeah, that's a big improvement for our ghost recorder. So while we are fixing small issues with the game, let's have a look at this one. So if we go into game and we can zoom in, we see that, okay, there is a tile here that is not properly lined. So if we press play as well, we will see that this is not looking good. And the reason why this happens is because the sprite sheet that we're using and how Unity is rendering everything. So to solve this type of problem, we can either use a pixel perfect camera, or if we don't want to do that, we can repack the sprite sheet. So let's go into sprite sheets, and this is the sprite sheet that we are using, and that is causing this type of problem. So let's create a sprite atlas, and we can call it sprite atlas tiles, and we need to make it a little bit bigger because this was quite big, and compression none and point. All right, so now we want to include what should be packed in this sprite atlas. So we press the plus sign and we want this sprite sheet tiles. So let's type sprite and there it shows up. And then we can hit the pack preview to see how it looks once it's packed. And there we go. And we see it here. So now if we press play, we can see that voila, this problem has disappeared. So that's a simple solution to get rid of these annoying problems that you can have with the Unity and the sprite sheet. Now the problem is that this file has become quite big. It's 32 megabytes, so maybe we want to actually make that smaller so we can reduce the quality of it to normal, and see if we pack it and see how it will look, if it reduces the quality or not of our game. There we go, it's 8 megabytes now. And well, I don't think you will notice actually any difference because of that. So that's a good simple optimization that we can get Unity to draw the tiles perfectly without having this type of problem. So now that we fixed those small things, we want to as well have a menu so that we can go back to the main menu or race again. So we will take a canvas, leaderboard canvas, and we will duplicate that one again. And this time we will remove the leaderboard handler, and let's call it menu canvas. And let's center this one, and let's make it wider, stuff like that, or maybe that was too wide. 800 maybe is a better size. And then we will take our background image and stretch it all the way. We will make sure that it is less transparent. And let's take our header text and change that to our outline. There we go, 3 and -3, and increase the alpha, and then change our. All Right, and let's make it a little bit bigger. 200 and center it. And let's increase our font as well. 80. All right, and that list can go away. So then we want to have a few buttons. So let's go and create, first of all, layout group, so we can stack buttons on top of each other. And let's add our UI button. Right, and let's put it on position 0, 300 maybe, and 100, something like that. And the text is really small for some reason, so let's bring that up. And we can actually press this best fit and hopefully it will work. And what we want to have is raise again as an option. And then we want to have another button, and they should be under this layout group. And the other option is going to be exit. Right, there we go. And the layout group, let's center it to upper center. And we can actually make this a little bit bigger. So hold on, maybe 500. And then we will increase our layout group spacing to 30, something like that. Raise again, exit. Oh, I think that's fine. And maybe bring this text up a little bit. Okay, so now we have our buttons and our canvas. So if we save that and have a look at the game, we can see that, yeah, it looks all right. So this will appear once we have completed a race. And then we need a script to actually handle that input, and also that it's showing at the right moments. So let's go into scripts, UI, create a new C# script, call it in-game menu UI handler, and let's put it on our canvas here. In-game menu UI handler, and let's save our canvas, and let's open our in-game UI handler in Visual Studio. Now, to speed up this video even more, I've already provided the code for this, so we will just review the code. So we have a canvas that we are getting in the awake, and then we are hiding the canvas by setting enable to false. Then we are hooking up our events, and we are also listening to on destroyed. If our game state has changed and has become race over, then we start a coroutine called show menu CO that waits for 1 second and then shows the canvas. Then we have two public functions, one on race again that just loads the same scene again, and then we have on exit to main menu, which loads the scene menu. So this is all that we need for that. So let's save that and go back into Unity. Now we need to assign our buttons so that they are using these functions that we have just created. So let's use the plus sign. Let's drag and drop our menu canvas, and let's select our in-game menu manager, and this is race again. So on race again, and then we do the same for the exit button. On exit to main menu. All right, so let's save that and let's take this for a spin and see what happens. So we have our countdown, and we can race. Alright, and then we have our menu, so we can press race again, and then it starts a new race. So we do have a tiny bug, and that's the timer. I don't know if you saw it, but it actually starts counting before the time has actually, well, before the level has actually started. So let's have a look at that and see what happens. So if we press race again, we see that first of all it's continuing from the time it had, because the singleton remembers what time it had, and then it starts over. And if we start from scratch, we can see that it's going to count to 2 and then actually start. So we need to fix that. So let's go into our race time UI handler. So if we look at our race time, we can see that, okay, it is getting its race time from this function. And so if the game is over, then it will return the time that it took. Otherwise, it's going to return time minus race start time. So while the countdown is active, this is actually going to return some value, because the race start time is going to be 0. So let's just add that as a if statement. If then if we have countdown, we will return 0, and then we will add an else if on this to fix that. Okay, so if we have countdown, it will return 0. Otherwise, if the race is over, it will return this final race time. Otherwise, it's going to take the time minus race start time. So that should be fine. So let's save that and try that in Unity. So let's take it for a spin. And it's not counting yet. And 0. And there's 1, 2. Yeah. So now it actually seems to work as it should. Alright. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out. Here's an example from our game, Total Arcade Racing, which uses this component for its physics, inputs and other powers. You can find the game on Steam, Xbox and Nintendo Switch. Please take it for a spin if you want.